going to learn how to solve linear inequalities. And the good news about solving linear inequalities is it's just like solving a linear equation. There's just one little rule we have to follow, which I will give you. If I'm asked to solve a linear inequality like negative 11x minus 13 is greater than 42, all I have to do is solve it like a regular linear equation with one rule. Here's the rule. If I multiply or divide by a negative number, when solving, then I need to flip the inequality sign. And remember what an inequality is. I was assuming that you know what an inequality is. An inequality are those symbols that are greater than, less than, greater than or equal to, less than or equal to. Those are the inequality symbols. So if I happen to multiply or divide by some kind of negative number when I'm solving it, then I just have to flip this inequality symbol at the end. So let's get into this first problem. I would add 13 to both sides first. And now I have negative 11x is greater than 55. To finish solving this problem, I need to divide by a negative 11. Well, I divided by negative when solving, so I have to follow this rule and state my answer as not x greater than, but x less than negative 5. Now, the instructions in your book are also going to say, and graph the solution. Okay? It's very easy. We just draw a simple number line. And this is saying that the solution is all of the x's that are less than negative 5. So here's negative 5. Negative 4 is over here. Negative 6 is over here. Since it is less than and not less than or equal to, I just put an open circle, and it is all of the x's that are less than, so I shade to the left of the negative 5. And that is how we graph the solution. All right? Let's do another example. Let's say that we had 4 times 3x minus 5 in parentheses plus 7 is greater than or equal to 8x plus 3. Well, the main reason I wanted to put this problem up here is to remind you of just some algebra things we have to do. First, we need to do distributive property here. 12x minus 20 plus 7 is greater than or equal to 8x plus 3. Then I need to combine my like terms here. Negative 20 and positive 7 make negative 13. So I have 12x minus 13 is greater than or equal to 8x plus 3. Then I need to get my x terms together on the same side of the equation, so I would subtract 8x from both sides. Leaves me with 4x minus 13 is greater than or equal to 3, and the rest of it should be pretty easy. Add 13 to both sides. 4x is greater than or equal to 16. Divide both sides by 4. X is greater than or equal to 4. Notice I never divided or multiplied by a negative number. So that means I did not have to flip my inequality on this problem. Sketching the solution is just as easy as last time. There's 4, here's 5, here's 3. Since it is greater than or equal to, I need to color in the circle this time on 4, since it's greater than or equal to, and shade to the right since it's greater than. Now, there are two possibilities I need to make you aware of. You could get no solution on these problems. How would I get no solution? Well, let's say that I had a simple problem like this. 4x plus 5 is greater than 4x plus 12, and I was supposed to solve that one. Well, I would get my x terms, try to get my x terms on the same side, subtract 4x from both sides, and the statement I'm left with is that 5 is greater than 12. Well, we know that's a bunch of malarkey. 5 is not greater than 12. This is a false statement. This is no solution. I could also get an answer of infinitely many solutions. We've seen this before this year. And all I'm going to do is just kind of tweak this problem that I just had. 4x plus 12 is greater than 4x plus 5. And if I subtract 4x from both sides, I get that 12 is greater than 5. Well, that is true. That's a true statement. So in this case, any x would work. The answer here is that there are infinitely many solutions to this problem. And that is a good introduction to solving linear inequalities, and hopefully that helps you.